I'm going to show you basically how to figure out kind of what stat to use, how to use the stat spreadsheet, and then I'm going to walk through a practice problem, not one here, but one on another set of data that should help you basically complete the stats practice problems here. Okay? So first thing you want to do is download this stats spreadsheet. So you click on that. It's going to go to here. You need to open it up in Excel or it's not going to work. So download this. Click on download. And then you can open it up here. Now, important, when it says here, it says alert. It says open as read only. You click yes. Okay, so it opens up to this. I'm going to update this. This will look different on yours, but I'll talk about that in a moment. And down here, you see all the different stats tests that can be used. Now, the ones we're mostly going to use are Spearman's rank, Mann-Whitney U, t-test, and ANOVA. We'll look at chi-squared, but much later. But those are the ones that you're going to commonly use. Okay? And basically what this does is all you got to do is put in your data here, and it does everything for you. But we'll talk about that in a minute. It's very, very handy. So if we go back to, this is my data. So this is some data from a couple years ago. So I have the height, age, gender, length of leg. Okay, now what I want to look at is what are the differences between the female heights and the male heights, okay? So what I'm looking for, so my question is there a difference in height between males and females? Okay, that's my basic question, all right? I'm going to open this up just so it's, okay? So before you start anything, we need our null hypothesis and our alternative hypothesis. So our null hypothesis basically is this. There is no statistically significant difference between male and female heights. Okay. Oops. Okay. So that's the same there. Now, the alternative hypothesis, right? So HA is very similar, okay? So still similar enough, I'm just going to copy this and make it a difference. So we're going to say there is a statistically significant difference between the male and the female heights, between male and female heights, okay? So this is kind of what we want to find out. This is our null hypothesis. This is alternative hypothesis. Remember, what we're trying to disprove is the null hypothesis. We can't ever prove the alternative, but we can disprove the null hypothesis. Okay, so knowing that, we need to go to this chart here. Okay, it tells us which stat to use. Okay, so first, do we have discrete or continuous data? So looking at the height, it's pretty much continuous. I mean, granted, there's a maximum height, but in this case, it's continuous. Okay, so we go down here, and basically, what are we testing for? Are we looking for correlations? So we're saying as one increases, the other increases, or as one increases, the other decreases? Or are we looking for differences? Is there a difference between those two groups? Okay, so in this case, we're looking at differences, right? Because we're looking at, is there a difference, kind of gives it away, in height between males and females? So then we're looking at the difference between two groups because we have males or females. Okay, and then we have approximately 28 data points here for females. So we follow this way because n here is greater than 20. So what we want to use is what we call a t-test. Okay, so now that we know that, we can go to this, and we want to hit on T and Z tests here. Okay, so students T and Z tests. Okay, what we're going to do is we're going to put the female data here, and we're going to put the male data here. Okay, so I'm just going to copy the heights because that's what we're interested in looking at. So I'm going to copy those, place those in here. You see it's already doing some calculations, great. And I'm going to take the male and copy those. And I'm going to stick those in here, okay? Now we don't have the exact same ones, that's fine. So what it does is it does all these calculations about statistics. I don't care about that. You don't have to show these in labs, you don't have to show them. What I care about is that you can interpret the answer, okay? So this one, it says T equals, that's your stat value, okay? So that's effectively your T value. So over here, I'm going to put our T value was 5.213, okay? That's just a number, not the 4 there, based on all these calculations. Now, what we care about here is the critical value, okay? So sorry, I'm going to put the T value right here instead. So what we care about is, so this is the T value, T, and this is the critical value. Now, for biology, we're at 0.05. For biology, that's just the accepted threshold for the critical value, okay? If you're in physics, it might be a little bit higher, and so forth. So our critical value here is 2.021, okay? So what that means is if the T value is bigger than the critical value, we say that there is a significant difference, okay? And that's what this is saying down here. The final result basically says significant at P less than 0.05, okay? Now it also says significant at P equals 0.01, okay? So that's fine. That just means there is a very, very measurable, strong difference here, okay? Now, if this value was below this, we will say there's no difference. The values are statistically the same. Okay, so going back to this was our question, right? Is there a difference in height between males and females? We had the null hypothesis. There's no statistically significant difference between male and female heights. Okay, and the alternative is there is a statistically significant difference between males and female heights. Now, if the null hypothesis was true, then this value would be less than this one. But because this value is bigger, what we end up doing here is we reject that one, okay? So we reject the null hypothesis, and we accept the alternative hypothesis. So what we're saying is there is a statistically significant difference between male and female heights, okay? So in the science lab, that's what you would write, okay? And then you would put your stat test used here, your value, your critical value, significance, yes. And then you would write a paragraph kind of doing this, okay? So what this means is effectively the chance of you getting this data randomly is less than 5%, okay? So 95% of the time, is another way to look at it, you're going to get this this difference is going to be statistically significant. Okay? And again, you can see how this might look. So for example, if I was to delete, I'm going to delete that. And I was going to make a graph of this data. So data, sorry. I was going to make a graph of this data. Okay, it's a column chart. Data range is, sorry, this is not working quite the way. But if you made a graph of the heights, you would see one was much higher than the other. Okay, supporting this idea that there is a difference. You can see that difference. So all this stats is doing is basically giving you numerical proof or statistical proof that there is a difference. Okay, so what I would like you to try to do now is download the spreadsheet. Remember, open it as read-only. And then I want you to download these practice problems. Now, when you download these, there's 4 questions at the bottom tabs here, okay? And it says, this one is determine if there's a difference between a single dose of absorbic acid, vitamin C, and the maximal grip strength, okay? And it describes a little bit here. So here, basically what you're gonna do is you're gonna compare the placebo, and which placebo, remember, is like nothing, versus the vitamin. So here's what, easiest way to do this is take this data like this, go up to data, and hit filter. And if you want, so filter, and then you hit this, and just do it by alpha. So then what it does is it's organized all your placebo and your vitamins all in kind of one spot. So that's just going to make life a little bit easier. Okay. Here, again, same idea, but here would determine if there's a relationship, right? So a correlation. And there's not much data there, but you should be able to figure that out. Question 3 is, here we're looking at 2 different types of ways of measuring head circumference. You need to see which ones, is there a difference between using the cardboard ones and the metal ones? And then here we're looking for a relationship, so correlation between these, okay? So what I'd like you to do is work through each of these problems using this stats calculator, okay? And we'll have time to go over them in class if you have any questions. And again, try your best. Don't expect you to understand this perfectly now, but we'll be doing lots more lab reports where you'll get to practice some of this stuff, okay? All right, thank you.